Okay, so good afternoon, good evening, good night, good morning, wherever you are joining us from. And welcome to the Woman in Data Science, Trinidad and Tobago 2024 Datathon Workshop Series. I am Dr. Leticia Addison, and I am one of the WiDS, as we call it for short, ambassadors here in Trinidad and Tobago as part of the Global WiDS organization. And we are really, really happy to have you all here today with us for the start of our sessions in terms of looking at not only the Global Datathon Challenge, but for those of you who are beginners or whatever stage you are in your data science journey, or if you're just an enthusiast passing through, we are here to help you on that journey to give you some insights in terms of what data science looks like. So I will just share my screen and walk you through how our day is going to look in terms of the presentation. Remember, this is an interactive session, and it's going to be a bit of an opening session where we're going to have a short presentation on what data science is about. And then we're also going to look into other aspects, for instance, in having our notebook. Could you just confirm in the chat for those of you who have joined us, did you receive the file? There's a file that we would have sent out this morning, well, whatever time zone you're in, with respect to the information for today's workshop. If you have not received that, that's no problem. Our mentors are here and they will drop it in the chat for you. So if you could just let us know in the chat, and we will put those documents for you there so you can actually follow along. So let's jump right in. So today's session is about data science essentials, what, why, and how. And it's really an overview of what data science is for some of you who may be absolute beginners. And then for those of you who are a little more intermediate to advanced, it's also going to give you an idea of our Datathon, or what we call a data challenge, which is a global challenge that runs for January to March and also from April to June. So there are two segments and we'll go into that. So just to give you an overview for those of you who may not know WiDS itself as a global organization, WiDS elevates women in data science globally. It started as a one-day conference at Stanford University in 2015 and has grown tremendously since then, with a number of ambassadors throughout the globe, including here in Trinidad and Tobago. And we support not only the conference at Stanford University, but also the Global Datathon Challenge, which has more than 4,000 participants annually. And there are also podcasts with next generation workshops, which include secondary school students and outreach in high schools. And of course, these types of monthly workshops and upskill workshops. For those of you who know about the Datathon, let's just give you a quick overview. And if you did not have a chance to look into it, it's basically what we call a data challenge. Some of you, if you're familiar with hackathons, it's like a longer version of a hackathon. And every year it's a social impact challenge. So what we do is we present you with a data set, and you can team up to be able to get certain insights about our data set, predictions, and actually be on a fun, exciting leaderboard with all the different participants over the world to see how well you are able to predict your model. Now, this year we have two different legs of the Datathon. There's one January to March, which is the current period that we're in right now. And there is also one from April to June. And we will tell you a little bit about the differences between those two. Now, if you want to know about what the challenge is this year, it's actually an equity in healthcare challenge. So it focuses on a metastatic breast cancer treatment data set, and it provides us with information about different patients in terms of their patient care, their profiles, their demographics, treatments, etc. So we're actually going to make you into mini data scientists, so we could see how we can create some meaningful predictions and insights from this data. So I'm not going to go too far into these because I just mentioned it before. Now, this is all available on the WiDS website, and some of my mentors, we will drop those links for you in the chat. And of course, it's really up to you which leg of this you want to participate in. As I said, you will have all these different workshops at your disposal throughout the period of time to support you in the challenge. So as I said, we have global events to support persons who want to participate. Now, if you want to be in a team, as I said, if you are just coming to see what data science is, that's totally fine, no problem at all. But hopefully we can get a few of you all to be excited enough to probably come on a team and participate and try something new. We want you to know that even though it's a woman in data science group, we do have male mentors and we also have male participants. So if you're building a team, you can build a team with up to 4 persons, but at least half the persons must identify as females. And of course, as I said, during that time, you would have access to all these different workshops, and the entire data challenge itself is lodged on a website called Kaggle. So we'll go into Kaggle in a little bit so you could see what that looks like. As for us, the Trinidad and Tobago chapter, for those of you who don't know where Trinidad is, we are a chain of a twin island republic at the end of the Caribbean chain of islands. So very tropical and sunny most of the time. And in the Trinidad chapter, what we do is we have virtual events, and we are also bringing on some in-person events at our in our space as well. So those of you who are interested in the series of events that we're hosting, every Saturday for the next month, we will have different parts of, in terms of the actual data life cycle and what that looks like. So today we're going to give you a total overview. And then in the next coming weeks, what we'll do is break down specific parts. I know sometimes these workshops are a little bit short, so it's a lot of information. So you're going to find yourselves having a lot of information today, but we're going to break down different parts of it each week, so it's more manageable for you. So I hope you would appreciate that part of it. If you want to sign up for the others, feel free to go to our website at WiDSTT.org. And this is some more information that we will also send out to you regarding the challenge, and not only the challenge, our events. Participants, if you want to team up with some of our mentors and participants in the Trinidad chapter, you can do so as well. And you can feel free to contact us at our email if you have any questions. So this is the more exciting part for me, to introduce some of my team members. I'll probably let some of them, if they want to turn on their camera or probably just say something over the mic. So I am one of the ambassadors. I have 2 co-ambassadors with me, Miss Rihanna Kandhai and Miss Priya Ramdial. And we also have a team of very competent mentors and contributors, as you could see them pictured here. I know some of them are in the room right now. I can't see the chat, but if you all would like to say something, Rihanna and Priya, you all want to start off and say hi to everyone. Even if you want some of you in the chat, you could also do so as well.
Hi everyone, good afternoon. Thank you, Dr. Addison. So I'm Rihanna Kanhai. I am one of the co-ambassadors for the Trinidad WiDS team. So I would be working with Priya and of course Dr. Addison on these workshops.
Excellent, thanks Rihanna. Priya, what about you? And I know we have a few others in the chat as well if they want to jump in.
Hi, good afternoon, everyone. My name is Priya. And if you all are feeling scared and you all don't know anything about data science, no worries, I was there. So if you all have any questions, you all could feel free to reach out to us.
Excellent, excellent. And I'm actually very glad that Priya mentioned that, because as I said, I know there'll be people in the chat who probably don't have a STEM background, and that is totally fine. And I'm telling you, if you don't feel overwhelmed initially, I'll be surprised, because I understand it's probably a different area for some of you, so that's okay. So that's what we're here for. If anybody else in the team is here, I will also highlight one of my male mentors, because I know that we would highlight the females a lot, but he's here in the chat, Nicholas. And when we move into the interactive session, Nicholas is actually one of our key mentors and contributors in terms of the materials and notebooks he creates. So in terms of our team, you can see we are a very diverse bunch. So we're all about equity and inclusion in that sense. So Nicholas is messaging you all in the chat, so you all could feel free to reach out to him. At this point, before we jump into like the presentation aspect, I just want a little icebreaker. You all could put what countries you all are from in the chat, but I also want you to let us know your data science background. So we're going to just start a poll. And if you could just quickly answer the question in the poll about if you're like a beginner, intermediate, advanced, where are you in your journey? So we can have an idea. And then we'll see those results before we move into our session. Right, so you'll feel free to jump in quickly there and let us know where you are in your journey. Just giving you a few seconds again. I'm seeing answers popping up. Okay, so let's see if we could see, can we show the results? Something, well, okay, I'm seeing some people answering, so let's give them a minute again. So far I'm seeing 52% at beginners, 40% at, okay, 38% at intermediate, 12% advanced. Okay, anybody else? Going once, going twice? Okay, let's see if we could, can we end the poll and show the results? I think we should be able to show the results, right? Let's share the results. Are y'all seeing the results on the screen? Let's know in the chat. Yes, okay, excellent. Okay, great. So there you have it. So that's what we're working with. So it's good to know. Okay, so I know I'm doing a lot of initial talking, but let's jump into the rest of it. So today's agenda, I will be talking to you a little bit about data science, giving you a little bit about the background and an overview. Before we jump into that, for those of you who don't know me, you can feel free to call me Leticia. In addition to being the Trinidad and Tobago ambassador, I'm also a project officer. I'm a statistical consultant at the Office of Planning at my campus, which is the University of the West Indies, St. Augustine campus. I usually say I'm a woman of many hats because I also serve as a lecturer in statistics and mathematics courses as well. And I'm also involved in a lot of different research in climate change and education, building predictive models for student retention, tuition costing, etc. So a lot of things are happening. And in terms of my background, I actually have a master's and MPhil in statistics. By now, you could probably tell I love math. I have a PhD in math as well. And I've also done a few certificate courses in data science and also been involved in data science curriculum. So it's really exciting for me to be here in this way because I actually really want to tell you all that one of the biggest things about data science is really involves a lot of statistics. And because that's the area I'm passionate about, I'm going to kind of push that area a little bit with some of you. If you haven't done statistics in a large way, that's okay. We have a little bit of a refresher tutorial that we will send to you in our resources. And I believe when the resources were sent out, it's in a table there, so you'll be able to see that as well. So let's just start with a bit of a conversation before we get to the interactive part. Data science. What, why, how? These are usually the questions. So by the end of the workshop today, you have some sort of understanding of the fundamental concepts in the world of data science, have some idea of assessment of like what are real world applications of the field, including careers, and then use the Kaggle platform. We will show you a little tutorial about Kaggle. And of course, if you want to enter the data challenge, you can feel free to do so. So it's really from theory to application is what's important. And we will share those resources for you for those of you who probably joined late and probably didn't get to access them. So as I said before, I will always start off with data science has its origins in math, statistics, and computer science, which have been around for a number of years. And what's really nice about it is that now we're not working in isolation in these three domains. We actually come together quite nicely to be able to harness the tools and the power of all these fields. So I'll always really tell people, if you want to know what data science really is, goes back to math and statistics foundations, and of course, computer science. And now it's grown quite tremendously. You're hearing things about machine learning, you're hearing about artificial intelligence, Internet of Things. And what's nice about it is that we can use the data we have to turn it into meaningful insights and actions, really, which is really what we want to do. So that includes things like data mining. We have other things like cleaning the data, analysis, visualization, and of course, we want the insights to be able to tell us how we could help change the world. So this is really one of the, I would say, quotes about what it involves on a much larger scale. And I think people sometimes just think about it in an isolated sense, like it's just statistics and math and these things coming together. But just remember, we have data in so many different fields. So you have to think about the subject matter that you're in, the domain that you're in, if you're in business, if you're in education, if you're in medicine, and how you could use that data to actually be able to build something meaningful. So it's really strategic. So I have a quick knowledge question here for those of you who probably just want to have a little bit of a quiz. That my lecturer at heart always wants to quiz my students a little bit, but feel free to answer if you want to or not. But if you want to think about it from everything I said here, what are the areas closely related to data science? You could feel free to drop the answers in the chat. And then what is really the main goal of data science? So I could let y'all think about it, or I think we could probably, from what I just said, maybe think that data science really does involve artificial intelligence, statistics, and of course, machine learning. And of course, the main goal of data science, by the end of this session, I think you would recognize what that is. And really, I've been saying it already, which is really to get those insights that we need to be able to make those predictions.
I think you're speaking on mute.
Oh gosh, sorry about that. You're hearing me now?
Yeah. But again, you are on mute. Yeah.
Okay, it's my mouse was really near the mute button. Thanks for that. Yes, so sorry about that. So why does data science matter? So it's really because we have a few different things that we have to think about. Converting valuable information. Data is meaningless unless we convert it. We have large amounts of data. We have big data that is sometimes organized, but in a lot of times it's very unstructured. So we need to discover the patterns. It also has a wide range of applications in our daily activities. I think we are all data scientists in real life, to be fair. And as I mentioned, it's really an interdisciplinary field where it's not only just the math, statistics, and computer. I'm thinking business and healthcare and climate change and all of these fields, things that matter to us, are an integral part now of the data science realm. So this, I know it's a loaded slide, but it's actually just giving you some of the applications in real life. Of course, in this challenge, and in the data we will talk about today is really to analyze patient data and identify patterns to make predictions. So in healthcare, we could see where it comes in. We could also see in climate change with respect to predictions in terms of natural disasters. And of course, transport, optimize traffic flow, reduce congestion, finance, predicting in terms of the market trends, detecting fraud. Then we have things like e-commerce, personalization of recommendations, and improving the customer experience. Even when you're on Netflix, Amazon, all of these places, and they tend to give you, the customer segmentation with the items that you like, the movies that you like, it uses data to do that. And then of course, things like image recognition, right? To be able to classify and recognize images as well. So that's just a few of the examples, but the possibilities are really endless. And this was a really interesting example that we came across, which really deals with the healthcare field in terms of Google AI, which developed deep learning, and how you can use that image classification in terms of, in particular, looking at lymph nodes and of course, breast cancer tumors. So you could see on the left, the dark zone and how you would have seen it before in terms of the processing quality, and it was poor. And look on the right side now, they developed a tool where you could identify the tumor in terms of the region and then classify the surrounding areas. So we are, it's really getting so advanced, all of these applications. And then of course, we could turn these images into data, tangible insights and data that we could use to make some predictions about this. So just to quickly talk about the data science life cycle, well, let's look at the basic components. If you're someone who has a statistics background, or if you have done statistics in any form, even in terms of business, you would really think about, you would have to identify some sort of problem. And of course, you'd have questions. And that's the requirements of whatever project you have or whatever problem it is that's in the real world. Then you would have to go about collecting data from relevant sources in different forms. And we'll talk about structured and unstructured very quickly. We have to process that data because, you know, you have to fine tune it. And that's really critical for the steps that we have to take in the analysis. And what you would recognize is that when we speak about the analysis, we would realize that a lot of the time we would spend in the data processing and then what we call like the data cleaning, etc. Because that is key in any field, regardless if it's data science, even if it's statistics, if it's just a simple problem that you're doing with a small data set with a survey, you have to look at the data, see if there's a lot of missing values in these things to determine how well the data, how robust the data is for what you want to actually predict. If there's a lot of missing values, you might tend to think maybe this is not the best data set for making a prediction or building a model or giving some sort of insight to someone about whatever the problem is in that sense. In the data science realm and in the data analysis realm, you're going to notice that we will use some more technical models that are going to sound really strange, but they all based on, if any of you all have heard of regression, majority of these models have a regression background in terms of prediction aspects. And we also look at classification type models, which is something we will talk about a little bit more in terms of the data challenge and how we can use these two types of predictions for the specific data that we have. The data modeling in itself now, when we prepare that model with different metrics, we can see now in terms of as we will talk about testing and training sets and validation, how that helps us to view the data in a sense of, is this data doing what it's supposed to? Is it predicting it well? And then we could form a model and deploy that model. And then there you go. You'll be able to have a desired model to say, well, I can use this now to make further predictions. So that's what it is in a nutshell. And that's how we will show you the full data set today in terms of the actual data analysis from beginning to end. But in the coming weeks, what we're going to do is we're going to break down specific parts. So if you're feeling like it's a lot when you see the notebook, don't be alarmed. It's really to kind of reverse engineer. You're going to start from the end and see how it looks to a data scientist, look at the different parts, and then each week we will go into separate parts of it. So next week, we'll have one of our mentors, Miss Malini Ramaran. I don't know if she's in the chat. And she will actually talk to you all about data science tools, even for persons who are not usually in data science, like, for instance, people who use social sciences packages like SPSS, even persons who use MATLAB, which is also a great tool for data science as well. And of course, some of the main ones that you might be hearing now, which we'll talk about today, would be using programming languages, including Python, as you see on the screen. Also R for people who have that statistics background. I'm very R is like one of my favorite tools. But I would also say I'm also a very big fan of Microsoft Excel or Google Sheets, those spreadsheet type programs that are point and click that you could get quick insights from. So you have a number of things, and then you have more advanced things like TensorFlow, etc. But all of these things are to tell you that there are different tools that you can use when you're exploring your data and want to build a model, but there will be ones that may be better than others in terms of the performance and the size of the data set, etc. Now, it brings us to machine learning, and that's something that you have been hearing a lot about, and you're probably thinking, well, how does that fit into data science itself? Let's have a look at that quickly. So machine learning is really a computer's ability to learn without being programmed explicitly. So it really, you'll be able to make predictions now. You see, in the realm, it's like you have artificial intelligence, where you have machines to think without human intervention. And then within that sphere, you have what we call machine learning, which uses these statistical learning algorithms to predict patterns over time. And then within that, you have deep learning. So there are different layers. And the machine learning aspect, you'll see that comes in a lot in our data analysis portion with respect to data science, because we want to make these predictions and we want it to predict as well as they can. So I'm just going to touch on this very lightly. For those of you who want to know more about these specific aspects, we will go more into the actual theoretical and then more interactive aspects in workshop 4 on these models themselves, but we will touch on them today in terms of what they look like. So supervised learning is what we would usually be doing, where we would have something based on looking at the specific data that we have, tasked with predicting labels to get new labels for the data. So we could actually have that learning problem. It's learning from the data in a supervised way. And you could actually classify it. You could actually have it as a category, or you could have it as a regression problem. So there are different ways that you can look at the features in the data, and that will tell you how you will predict, what kind of prediction that you would want to use. Do you want to label it as a yes and no problem? Like when I do student retention, it's either they dropped out or they stay in the system. Or do you want it to be a regression problem where you're looking at it in a numerical sense, maybe over some specific time, etc. Unsupervised learning is really unlabeled data, which finds groupings and structures in the data. Now, we wouldn't specifically do that right now in this portion of what we're doing for the Datathon, but it's something that you can go further into if you would like to. And here's just a fun diagram to tell you that cycle for machine learning in itself and how that looks and how it falls into the whole scope of everything. Collecting the data, defining the objectives, and which is really part of what we were speaking about with respect to the data science life cycle. But you would see now we went a little bit more in depth in terms of things like cleaning the data, looking at the variables themselves, seeing if we need to look at creating new features, if there's too much missing data, how does that impact the model? Is there any bias involved in when we look at it? So I'm asking you all these questions now so that when we go through the interactive portion and we see some graphs, and we actually clean the data, and then you see graphs, and we change some part of it, and you see another graph, you'll actually see how it changed in terms of we took out something from the data and we looked at it in a different way. And the exploratory data analysis is very, very important. So they call that EDA for short. And then that funnels into the data processing aspects, and then what we call the training and evaluation and deployment, etc. So I'm not going to go through this in detail right now. As I said, these are the steps that we will go through in the file, but just to let you know, this is how the exploratory analysis would look, where we look at the attributes and different univariate for one variable or bivariate for more than one variable, two variables, etc., multivariate, multiple variables, looking at relationships, correlations, types, interactions. And we look at these things first because we want to see if there's some relationship before we jump into the modeling aspect. So that's key. And then we also want to think about even identifying outliers. Besides the missing values, is there something that's making the data very biased? Is there something we could take out of the data? And that leads to what we call feature engineering, another big term, but it's really just looking at variables or features and then determining what we want to do with them to collect more insights for further data analysis. And this is the key part. So when we actually do our analysis, we'll be looking at training and testing and then evaluating these machine learning models. So just on a high level now, you could see the way it looks is that we look at building our machine learning model on the training set. And the training set in itself provides the outcome, or sometimes you would call that the ground truth. And this is used to create new features. And then we'll have a test set. So you will see these terms on Kaggle when you actually go to download the data. So it's important that you understand what they mean, because you'll have these different files to work with. And you would see how well your model performs on the test set based in terms of the unseen data. Because remember, we want to actually make a prediction of data that we could probably get in the future based on this particular model. So you have to use the test set, use the model you trained for the prediction. And then, of course, you could validate those results in the end. This may look a little complicated to some, but this is just like a high-level view of preparing the data, building and training the models and what that entails, and then deploying and predicting. I know it's some very big words in terms of hyperparameter tuning and all these things, but when you see it in steps, and it's actually all involved in when we talk about the actual data life cycle, you would see how each part works with each other to make a robust model. So what you will be doing in the challenge is that once you reach the prediction stage or you build a model, you would eventually want to consistently see if there were any aspects of the model that you can improve. And that's what happens in real life with these models. They are consistently being trained to ensure that they are really the most accurate model for the problem. these slides I'm going to just breeze through very quickly, and I can also post the slides in the link for you all too, so you can always go through it on your own time. But these are more just kind of a stepwise look at all of these steps and giving you snapshots for people who probably have different backgrounds. Like here you would see data collection could involve for persons who in computer science, web scraping. I know people who in social sciences will do more things with surveys. You would have people who are looking at APIs, data acquisition, etc., data mining. All of these things are part of what we call the data collection process, and you could have a combination of them. Then the data cleaning that's the aspect where we say that's really one of the most important parts. And this would really help you to figure out if you need to fill in gaps in the data set in terms of the missing values, which we call impute the missing values. If we want to look at identifying anomalies in the data in terms of the outliers, if we want to convert different types of data, because remember, we could have numerical data, we could have data that are more in terms of categories. So if you want to encode them as categorical, you could actually change your features and that sort of thing, and then scale them. So I always tell people, and this is even just from statistics, the variables that you have and the way the variables look are really important to tell you how you deal with it. Is it a numerical variable or is it a category? And then you could have variables that you could actually change them into different formats. For instance, you could have like, say, body mass index, which could be a number that's recorded by a doctor. And then someone else might say, well, I really prefer to look at this in a category of maybe small, low BMI, medium, high, whatever the categories are. So you can actually change your features to suit depending on the problem. Most of us should be familiar with some of these types of graphs, so I'm just mentioning some of them, and they go with the different types of data, so you'll see that in our breakdown as well. Just to remind people, as I said, for beginners, what we will be looking at first is really visualizing the data. That's the first thing you should do with any data set, because we really want to see how it looks before we just jump into trying to figure out how to model the data. And it really goes with different types of visuals, which we'll talk about further in our next workshop 3, we will talk about the data visualization. And then, of course, the machine learning aspects, as I mentioned before. There are other aspects like reinforcement learning and deep learning, as I said, we wouldn't go into right now, but the supervised learning is really important for us to train the model with labeled data to make those predictions. And I just put in this for anybody who's more advanced in here, if you're into natural neural processing and that sort of thing, text classification, sentiment analysis based on sentiments expressed in text. And then, of course, topic analysis, speech recognition, all of these things are important. So we also have all of these things you could see as part of the applications. And as I mentioned before, we had specific applications I spoke of initially with data science, and machine learning, of course, will involve some more detailed versions of these applications in terms of even self-driving cars, the traffic prediction, product recommendations, as we said. So it's really a vast area. And because of the applications, there are a lot of different career options. So people would think it's just a traditional data scientist, but I would say a statistician also acts as a data scientist as well, because as I always would say, data science really has a lot of the origins in statistics. And of course, a data analyst would do similar things, but of course, computer science is really plays a key role now because of all the software we have, because we have moved from just paper-based into the more virtual realm. And then you have like data architect, you have technology officers, you have a lot of different people, market research analysts, data application architects, etc. These are just a few of them, but it's really vast. And of course, I think you all know there are a lot of courses online that support the field as well. So does anybody have any questions? If you have any questions, you could place this in the chat. I know this was just basically to kind of whet your appetite a bit for you to get some excitement for those of you who for the first time have been looking into the data science field. But let's go into a demonstration of what we're going to do today. So I'm just going to speak about what the Datathon is in terms of the website. You could go further into the website to learn more about the different timelines for the Datathon. And if there are any of you who haven't signed up now, if you're not sure if you want to compete yet, you can still sign up. And the reason why I'm telling you is because it'll be nice for you to actually go on the page and register, so you can go on Kaggle and be able to see the full data set, because I will show you how it looks on Kaggle. So you should have a Kaggle account for that purpose. And I will just show you a short video now on some of the basics behind Kaggle. So let's just jump right in. And then after this, we will look into so I will just give you all a heads up. After this video, we will go more into the interactive notebook that I had sent via email. So if you didn't get it via email, check in the chat for the link so you could prepare those things, maybe download the file so you could have it there. So by the time the video finishes, for those of you who want to do the notebook, you'd have it to be able to go through. So let me just play this for you in the meantime so you could have an idea of how Kaggle works.
Let's have a look at the WiDS Datathon 2024 challenge hosted on Kaggle. So you already have your free Kaggle account set up and have signed up for the WiDS Datathon challenge. Once you have done both of these, you can navigate to Kaggle and be able to peruse the Datathon website. You'd find particular tabs that are related to this specific challenge, and the overview is based on an oncology dataset where you'll develop a model to predict if patients received metastatic cancer diagnosis within 90 days of screening. Of course, bear in mind that this challenge started on January 9th and closes on March 1st, within which time you will have to look into workshops and also be able to form teams. A quick look at the description, and you can see that the data set has been sponsored by Gilead Sciences. It's a real-world data set which contains demographics, diagnosis, and treatment options, as well as insurance provided about patients who were diagnosed with breast cancer from 2015 to 2018. As you scroll down, you would find the submission format for the competition. Just a reminder that in this competition, you are able to compete with up to 4 persons on your team, and at least half your team being females. Now, the submissions here have a particular format. If you would notice, as we scroll down, you can see that there are various tutorials and resources that you can jump straight into, in particular, Introduction to Kaggle Competitions, Getting Started with Kaggle, as well as specific data science tutorials to assist with the challenge. Of course, you'd see there are various prizes that will be allocated for any of the global teams who reach the top of the leaderboard. Now let's have a look at the specific data that's associated. So as we mentioned before, this data set is based on breast cancer diagnosis, and we are focusing on a prediction task. So as we could see in the description of the data set, this has 39,000 records split into 2 sets, tests and training sets, and we will learn more about these as we go along in these workshops. Now, in these 2 sets, which we will use to build our prediction model, we have patients with characteristics such as age, race, BMI, zip code, diagnosis, and of course, treatment information as seen here, as well as zip codes and air quality data. So the 2 data sets you would see are a training data set labeled train.csv, which is a comma separated value file, and the observed values of the outcome variable being diagnosis period being less than 90 days for each row is provided here. The test data set is where we withhold the observed values of the outcome for each of these rows, and we will use this on our training data set to determine how well our predictions are doing. Now you're probably thinking, what does the data set look like? Let's have a look. Now this page contains a lot of the information on the data. For those of you who are beginners, it may feel a little overwhelming, and that's okay. What we really want to show you is a sense of what real life big data looks like. So our target variable, as we mentioned before, is listed here to indicate whether the cancer diagnosis was within 90 days. And we also have columns, as we will see shortly, which represent the different variables associated with the patients in the data set. As you can see, there are a lot of columns, but don't worry, we'll help you to analyze these and get your predictions done quickly. Now, for the efficiency of the process, we can see here, there is a table that you can actually look at each of the CSV files. So we mentioned before our training set. And as you notice, you can see all the variables, and there are 83 columns within this training set. You can download this CSV file onto your machine, or you can work with it within the Kaggle workspace. We also have a test set, which has similar variables. And of course, as I mentioned before, it does not have the target variable within. Now notice that within these columns, you can see the spread or the distribution of each of the variables. And it's really an important step that we will speak about, where you should explore your data set before you jump into any sorts of analysis. So for instance, if you would like to look at specific variables, you don't have to select all the columns. For instance, if we just want to look at patient race, payer type, patient state, we can look at those specific variables themselves. And you can also see where there are missing values within those specific data. So we have a submission CSV file called sample submission. And this is what you will be submitting for the competition based on your predictions. You would notice that it just boils down to the patient ID and the predictions based on that target variable, as we mentioned before, with the 90-day prediction of cancer. So of course, at this point, it may seem, how do we even do this? Well, we would need some tools. If you click on code, you can get an idea of what it looks like. For a beginner, it may seem, how do I even start? Well, that's not a problem. We'll show you in a stepwise way. For those of you who are intermediate and have an idea of programming, you may find this to be an easier process. If you would like to jump in and see what others on the space are doing, you can feel free to click on code and click on any of these notebooks. Within these notebooks, you can actually see what we call the coding aspect on the back end of how their models work. And you can save these notebooks, copy them, and run them on your own time. In this way, we are all learning from each other, and that's one of the benefits of being on Kaggle. So that's just a quick look at the coding aspect. And of course, we will delve further into this as we go along. Jumping back to the challenge page, you can see there that there has no models yet. Models from Kaggle will be posted here and will be in the public competition notebook. There is also a discussion forum for those of you who have questions, would like to meet up with global team members, and want to see how specific coding works. And this is the most important part for you. When you make your submissions, you have to look at the leaderboard to see where those submissions go in terms of the scoring. Now, of course, you can come up with your fancy team names, or you can compete in a single sense. However, your scores will be based on a metric. And we'll talk about that in a little bit. Of course, you should read through the rules regarding how many submissions you can make a day based on your predictions. And bear in mind, you can consistently improve your model predictions as you go along. And that's the purpose of these workshops, to assist you. Team formations will also be on this page, and you can invite persons to be on your team. So in terms of the overview, remember that we are making predictions based on this specific variable in terms of the 90-day predictions of breast cancer. We would also want to bear in mind that we have to look at the RMSE metric, and we'll explain those in our workshops. And this metric will be used to determine how well your model predicts from your data set. I would encourage you to jump into some of these tutorials and resources if you would like further information on using notebooks, and also what exactly is this challenge about in terms of the biological aspects and how we can assist in building models to predict such. Now, the submissions for the leaderboard are evaluated under the area under the ROC curve. As I mentioned before, it's a metric, and that in that metric, you'll be able to see how well your model predicts, and also if you need to make any further improvements based on these predictions. The submission format, as we mentioned before, is a CSV file. And of course, this is how it will look. So as we go along in our workshops, you will see how to create that submission. When you are ready to create it, you will click on Submit Prediction. And of course, you'll be able to put in that CSV file. Of course, there are various ways you can actually analyze the data through notebooks on Kaggle or Google Collab, or you can also look into analysis through automated tools. Some of them are included, like MATLAB, which has a license for persons entering the Datathon, or any other automated machine learning tools for more intermediate and advanced users. So how do we even make a submission or even analyze the data in the first place? Let's jump into looking at how to use a notebook to do this.
Okay, great. So does anybody have any questions on this specific portion of because we are almost finished with the presentation and we want to go now into talking about what we're going to do in our actual.
What's going on, guys? In this video, I want to start documenting my progress in doing Kaggle challenge.
Right, so let's get started. So for persons who have the information that we sent in terms of the notebook, we can also, I think we put this in the chat as well. So let's look at a short tutorial. Now, this tutorial is based on a version of the same data that's used in the Datathon. It's one from what they call the university challenge. There's also a university challenge based on the data set. It just has a slight difference to what we are using for the global challenge. So it's the same predictions that we are doing. Right? I think I sent you all these steps. So what I am going to have to do is I'm just going to switch my device. If anybody's getting any trouble, can you let me know in the chat if you are all able to access the materials in the folder so that we could get started? Now, this is a 90-minute session today, but we will take about 20 minutes to go through. And then, of course, we'll have some few questions after if you all want to stay back, anybody wants to stay back. Is everybody able to access? If you can't access it right now, you just want to follow along, that's fine as well. And then we'll give you some homework to run through as we go along, right? So these are the steps for any of you who are interested. This is actually what we're going to look at. And I'm just going to switch my device. So you could just give me 2 minutes. Let me just switch my device and I will bring it up in the notebook so we can follow along. Just confirming, is everyone hearing me on this end?
Yes.
Yes, y'all are hearing me? Okay, excellent. Okay, so I'm going to share my screen now. And let's have a look at, so this would be the notebook that you would have received within the files. Now, let me just quickly show you the files that we would have sent. So you have all the resources. So as I said, you can work at your own pace. We're just going to give a quick overview. And before I jump into the notebook, I will, as I said before, like to give very special thanks to Nicholas, one of our valued mentors who has created a lot of these materials for this notebook. So feel free if you have any questions as well to reach out, and he's right here today. So if I miss out anything, Nicholas, you could just let me know and you could jump in one time. Everything about the data set is inside here. You would also see these files called tests, train, etc. and sample solution. I put a zip file as well, but you have these single files as well in here. And then of course the notebook itself. Now, for persons who never used Google Collab before, it's really like it uses these cloud services from Google where you could actually have everything here in a shareable format with all your code, and it's editable. Now, I know I would have sent this file. I would advise you to probably save a copy of it in your drive instead of trying to toggle with the one I have here. And then what you would need to do is we would only have to make one small change in terms of where you have the files lodged. So before we jump into the steps, this notebook, this environment would pull on those tests and training sets that I mentioned to you all before, which are in the folder here. So you can download them, or I would advise you to probably put the full folder into your drive. As you could see, I have it in mine. And what you would want to do at this point is create a copy. Well, you can create a copy. I'm trying to work from the one I was working on before. So I'm hoping I don't slow down my speed right now. It's taking a little time. In the meantime, Nicholas, if you also have it and you have to share screen, I think this was a problem. I had a technical problem yesterday with this laptop running it here, as you could see. So if I have to let Nicholas go through it and I will verbalize the steps, we could probably do that too if this is taking too long. Nicholas, do you have it on screen by chance? So we could share it from your end?
Just give me 1 second, yeah.
No problem. Yeah, I think my own is giving a little trouble. Let me just refresh the page. Anybody has it running, or are you all just watching these steps in the meantime? So I will just refresh the page. Yes, I think Anthony is asking, will R be used? Yes, thanks for asking that, Anthony. So I know we're talking about Python today because Google Collab actually uses Python. For beginners, that's just another programming language. However, I will say I am a little biased towards R because I use R a lot. So we will be showing you a tutorial on R in the next session, which is next Saturday. But today's session, we're just going to show you one of the main tools that they use, just for you to get a gist of like the most popular tool. Hope that answers your question. Rosa, thank you for making a copy, right? And Faith, yes, you have access to it. So I'm so sorry, guys. You know what happens live sometimes. And this morning it chose to give me some trouble to run. So once we can get it up and running, but it's actually running, it's just I think my system is a little slow. So let me just close a few of these windows and see if that frees up some. I'll just refresh the page again. Let me just stop sharing for a second and let's refresh the page. In the meantime, though, for those of you who are able to open it, what I will tell you the steps would be you would have to actually save those files in your drive so that when you run it, you'll have to change the directory. So that's the step we're going to do now. I know some of you are able to do that step already, Let me just refresh and see if I could reshare this page.
I can share if you want, Dr. Addison.
Okay, sure. Thanks so much, Nicholas. So Nicholas will share and we'll just walk you through some of these steps. Now, this is a very long notebook, and apologies for the technical glitches. My laptop was misbehaving this morning, so I'm very sorry about that. So what we want to do is walk you through in what we decided to do is show you how everything looks. And for beginners, as I said, I know it may look like a lot, but what you will do is you'll walk through these steps in a reverse engineering aspect after, which means you will go back to certain steps in the tutorials, as I mentioned. So thanks so much, Nicholas, for that. So I've probably been overworking my laptop quite a bit. I think Videsh has also put in the little review of how to use Google Collab. So let's get started in terms of the data, the actual notebook. So once you have it, as I mentioned before, copy it in your drive. So you have a copy of it. And you would want to start running now, right? So yeah, so he's showing you to save a copy in Drive. So you would actually end up seeing copy of WiDS. If you want, you could eventually change your name at the top if you so desire. Now you would see a lot of different codes. So Nicholas is changing it to my version, which is great. So those of you who are following along, you could probably do that. And as I said, for persons who are not accustomed seeing this, it's going to look a little bit like, wow, there's a lot happening. You're seeing all these things that are looking like strange language. Now, remember, I always like to tell students and participants that just like we learn other languages, Spanish, French, Italian, some of you may be learning English, this is just a different language and it has its rules. So for this purpose, because it's a shorter interactive session, we're not going to go through all the specific rules right now of Python, which is the language this is hosting, but we're going to actually show you in a general sense how the language works all together to build out the actual predictions, the visuals that we want to see. And then, of course, as I said, we will go into different steps. Now, I placed a really nice set of resources for absolute beginners, so you can actually see what happens with the language from scratch. So we're showing you from a more higher level. And if you have any questions, go ahead, right? Any chat. So as we go down, we could see, we have to import the data into the tabular data set. I would have had those steps earlier. So as we scroll down, what that means is libraries in terms of what the language is. So we're going to have to think about different tasks that we want to perform. And because we want to perform different tasks, just like our library has a whole set of different books with different areas, right? The Python language has its own libraries to perform these tasks related to manipulation of the data, visualizing the data, building the model, and pre-processing. And all of that is written in this language here. So you will see a lot of these words like pandas, numpy, matplotlib, and all of these things as we see on the screen, right? We are importing or we're pulling those libraries because we want to access them into this specific notebook. Because this is like a virtual notebook. Pretend you were writing in person. This is like a virtual version of that. And we have all these libraries here. So it's a number of them because it's a number of different tasks we want to perform. So it's like we call it a workflow. And of course, you could do these things from scratch. Of course, as I said, this is a higher level. So Nicholas is going to connect where he's clicking on the little button here, right? So he's showing you how all of these things work. The little play button actually executes the code. So it runs the code now. Anybody has any questions in the meantime? As I said, I'm not too sure who's following along with it right now, but if you have any questions, feel free to let us know. And as we go down now, we could see once we have our library set up for the data set and the libraries are imported, this library, as I said, is the major one is called pandas. So you will notice for just a simple statement, we will be using pandas.read_CSV, which means that we're going to use this library called pandas to read the data in the CSV file or the same comma separated train and test files that we had, right? So we're going to have that stored. So what we have to do first of all is to actually what we call mount it into mount your Google Drive. So it's going to access those data files. So we need to click on the little play button, as you can see there. And then it will ask you to connect to Google Drive. And in this case, of course, it will connect to your Gmail account. And it will ask you for permissions. So you click continue as you go along. And it may take a little time for different persons. Remember, this is also using some of the memory inside of this cloud service. So you'd say it says 27 seconds to execute. Now, what we want to do is we want to pull the actual files that we have. So you could click on Drive, as you could see there. And your drive will have your files. So you'll see My Drive. And in terms of this drive, we have the data saved in one called Collab Notebooks. Now, I would have had it written differently in my own. You would have yours written differently where you have it saved. So the most important thing is that you see that load the data sets area. The only thing that you all will be changing would be the path or what we call the directory to locate the file. Because now what we want to do is we want to pull what data we have from the outside and import it into the space. Does anyone have any questions on this specific aspect? If you do, please let us know. For absolute beginners, let us know if you need us to clarify anything. Because this step is crucial. If you get an error, it would mean that it's not what I call pointing to the correct folder where the files are. And don't be alarmed by that. Please wait a second. No problem, Rosa. Let us know where you are. I'm glad to see that you are following along. So in the meantime, while you all are doing this, just letting you know that if you do get an error, that's okay. I would tell you personally, I was working in a different folder. I realized and I had 2 folders with the same name. Something happened this morning and it was actually giving me an error as well. So that was so important to run the file in the specific place that it's supposed to run. So if you get in any problems, let us know and our mentors will help you out in the chat.
I think you could talk about the alternative step by
Yes.
uploading it directly to the session.
Right. Thanks, Nicholas. So in addition to that, if you want to have it in a permanent space and just have it there all the time to lodge, you could do that. If you want to actually just run it within the session, but this is temporary. So just note that if you upload it to the sample data folder, right, you could upload it into the session here, well, in the sample data if you want. And if you have it, as I gave you all, if you saved it on your machine, wherever you have them saved, the train and the test set, you could actually run them there. Now, I know sometimes you might get some warnings and that sort of thing. Remember, as I said, this works on the memory of the system of the actual page and this collab page, depending on how many processes you are doing also. Rosa, did you get through on your end? I saw you said you were uploading. Let us know, right? Because we don't have to go too quickly because we have all the information here just to make sure. You got an error, say, Shade? Okay, so I'm seeing Shade got an error. I think it's based on, and did you have it in your drive? Do you want to put it in the session folder? You want to do it over that step again, Nicholas? Let them see. If you're getting a problem with putting it in the drive, what you can do for this purpose is just put it into the session for now, which is where, so you'll just rerun that step again. So you could save the train and test set on your desktop somewhere, if the drive part of it is giving you trouble, and just actually upload it to the session. So you go to the top button right under files here, it's like an arrow pointing upwards, and click upload to session storage. Let us know if that one works to upload it. So you're uploading it first before you run the coder. So you're not going to run the code yet, you're going to upload it first and then run the code. Okay, so as you go along, you'll let us know and we can assist you. Right. For those of you who did get it into the drive though, you would have to change the actual, Yes, Rosa, yes, if you didn't get an error message. Once you change the location of the file where it's in your cloud. So where you have the file saved, the path, it has to change to wherever it's saved in your drive. And you could click run and see if you get any error messages. And as I said, don't be alarmed if you get error messages, that's fine. It just means that you just need to make sure the location is there. Sure, Nicholas, Shannon's asking to redo the step to upload it to my drive. So we'll go through that again. So remember to run this part first, right? So we're going to run the part under after libraries, the yellow bar, run that first, right? That's to make sure that you're actually mounting, it's actually going to point to the Google Drive where you want to access the files first and foremost. Are y'all seeing that? Drive is already mounted. And then once you see that now, you go across on this side where you see that folder icon, you click on My Drive as you see on the screen. And you could upload the folder that you downloaded into the My Drive here. Now he has it already saved in his drive already. We already have ours saved here, but you all could actually save your folders there. Or you could have copied the same folder from your email into your drive that I had sent by email, and you could have it. So once you see it, it should look like this. His own is named WiDS 2024. I think I named it WiDS Workshop 1 2024, etc. The long name. And you should see the files. So if you're not seeing them in here, it means it's not what I like to say pointing to the folder. So let us know, because as I said, it's okay if you all we take a little time on this step, because after this, everything else will go faster once you get through here. So let us know as we go along, right? So we'll move along, and if you have any problems still, you could let us know. So once it's there, and remember the path, as I said, has to correspond to where it's saved now. So you would have to change this to whatever name it is, /my_drive/ whatever WiDS 2024. You have to change the name of what we call the directory of where it's saved. And as you go along, so you're going to click load the data set. So once you click the play button here, I like to call it the play button, you would actually, it's the run button, in fact, to run the cell. So what it's doing, it's running all that code, it's executing the code. If you don't get any error, you'll be fine, as in you could go along to the next step, right? If any of you still get errors, we'll come back and assist you with it as we go along. So you could follow on for now. So what we're going to do is we're going to say, we're going to look at the regression section. Renelle, we'll come back to you in a second, right? The regression section. So as I mentioned before, we spoke about all of these things. We're going to do a few steps in terms of looking at the importantly data set. So we just did that. Now we want to look at things like cleaning and pre-processing, exploring, all these things. So you all could always read through the little written parts that we have there. So we're going to actually do what we call EDA, or exploratory analysis. So first things first. Now remember, this data came from what I like to call it is like a worksheet, a spreadsheet, right? We want to actually see how it looks in here to make sure it's the same thing we're looking at in terms of what we're analyzing. And then we want to visualize and look at relationships. So the goal is you really want to see if you have the data that's sufficient for the task, and if the data needs to actually have any additional processing to it. Now, what EDA does is allows us to have a snapshot or summary of the specific variables and what they are. So for instance, we're looking at a little snapshot here of some of the data that we have in terms of when I mentioned in the Kaggle video earlier. We have patient ID, patient zip code, patient age, BMI, etc., breast cancer diagnosis in terms of the year. We have the count in terms of the number of values, the average values or the mean, standard deviation, minimum. We also have percentile values and the maximum values. So we actually get a true picture. And the thing about it is, if any of you would probably think about, why would I want to see a snapshot of it? Is really because, for instance, to me, I would be like, okay, let me first jump to the ages. Are the ages in the study feasible? Were there any errors? For instance, if I probably see the minimum age we are seeing here is 19, right? If I saw an age, minimum age of say 0, and a maximum age of say 500 or something, I could tell that something is off with the data. right? So we have to actually do this to have a snapshot, because remember, we can't go through every single value ourselves. So we have to look at what it looks like in a larger way, and then we could break it down as we go along. So what that means now is we have a snapshot here. Remember, we have a lot more variables in the data set, but we're just looking at a quick snapshot of some of them. So we need to extract insights. So we're going to ask ourselves questions. How do we do this now? So we could use different functions. So in terms of what we call the describe function, this function, if you run this function here, it will summarize these values. So the snapshot that you saw up there, based on the data, you could actually run the code here and then display basic statistics in terms of that training data. So when you click run cell to execute, this is what you should see once you're not getting any errors from before. As I said, the persons who get any errors from before, we'll come back and assist you with that. So do have no fear. So here now I can see in a more like a nice overview of each of the variables within the actual data set. Now you see a number of them, and you could go through, because remember, you can't do this in isolation. I would also like to remind you, you should research the field and understand what are the traditional trends in this area before you just delve into it, because you have to have some of the background knowledge as to what's going on. So we have things like breast cancer diagnosis, population, we have different ages, etc. We may not need all these variables in the end for our model though. So just cautioning you, right? So remember, we had about 83 we started with. So as we go along, we may want to look at the actual target variable. Remember, we had a treatment variable. The target variable is the one of interest that we want to predict. Some of us will call it a dependent variable in statistics, and we want to be able to use other variables within the data set to actually predict this one. That's what's important to us. So we have a little write-up about summary statistics and what they mean. So you could read through that in your own time for those of you who need a little bit of a refresher. But in terms of the target variable, we're looking at the fact that we have a certain number of non-null values, meaning that they actually have values within the column, meaningful values, indicating that you have no missing values for that specific one. If you have a lot of missing values for your target variable, that could also be a problem. So let's go down and see how we can look more into describing data on a single column. And I'll just remind you all, if you have any questions, again, feel free to let us know. So we'll run this piece of code. And for those of you who don't necessarily know what the code is yet, you could sort of piece together just by looking at it in terms of how it's named and what's doing. So for instance, we have the trained data, we call this regression, right? Because we're actually going to build a regression model, a prediction, a simple regression or prediction model. The treatment PD in brackets is the variable of interest. And then we put dot describe. So we're going to take that describe function and actually get the summary statistics for what we put on the left of it. So all of that information on the left is what we actually taken from our data set. And then we're going to describe it. So you see now how it looks. And you see these different values. We could see the mean value is 134.218, etc. The standard deviation. And we could also see that it has the name and the type, which is called a float, which is basically like a numerical variable or decimal value. And that's important because we need to understand the types of variables, and we will go more into the types of variables in our next session. Up to this point, if anybody has any questions, to let us know. So moving along, we have the summary statistics. How do we now display the summary statistics in terms of like numerical values? Because as I said, we have different types of, just think of it like in real life, you could have data and categories. When you answer surveys, you could have yes or no. You could have even categories of, as I said, the body mass index, low, medium, high, or you could just deal with even the age groups. You have age groups in your surveys, and then you could also have the actual patient age. Now, when it's numerical, this is a code that we could use to actually just extract the summaries for the numerical columns in the data set. So we run this code. And you could see on the left-hand side, you're seeing how it's not showing you every single, but it's actually telling you at the end is 27,674 rows by 70 columns. It's giving you a snapshot of it, right? And then you have the different variables here, the patient ID, etc. As you go across, you could see that it gives you an idea of all those values. So it just gives you something to think about when you actually analyze it. And I would like you to be very, I don't want to use the word skeptical, but I want you to be very observant in this process. This exploratory process is a process you should take some time to look into it and really appreciate what the data is looking like and what it's doing, and if it's looking like it's meaningful for what you're trying to predict. And that will tell you a lot. So as we move on from here now, the numerical columns. Now, in terms of quantitative, I was trying to use simpler terms, numbers and categories, but we call these quantitative data, numerical data, right? So we have a little write-up on what those mean, and they have different types. And of course, we have a statistics actually an open source statistics kind of notebook that you could look into to actually look more into if you want to get a refresher for some of you. But numerical variables could be both continuous or discrete. They could be whole numbers or they could be decimal points. So all of this may sound very elementary, but I'm telling you, it gets really important when you're going to work with very big data. So as we go along now, we could see in terms of, as we mentioned here, that's where we will get the spread of the data, the distribute the nice summary statistics to tell us what the features are. Any of you would like to try to figure out how we can look now to analyze the distribution of the numerical features? And this is actually, the hint would be what we did before. I know some of you, as I said, will get in some trouble, so you may not be able to run this step. But any of you who would like to try, the question mark is where you put in what you should have here at the beginning. And the describe function is going to describe what you have before. So if you want to look at the distribution of the numerical features, so remember in the step before, we looked at the numerical features in a table and we ran some code. So the hint would be, if this is telling me the numerical features, I could copy and paste this whole code here, and now I could go a step further and then put in the describe function. So we'll copy and paste that code from before and just put it where the question mark is. Now, for running the code, one important step is you have to make sure it has, I don't know if some of you call it a hashtag, I know it has a number sign, that symbol in front is to comment off things so it would not run in the code. If it's there, it will not be active. So you see that we removed it so we could actually run the code now. So we could execute this cell. And now you see the summary. So before you were seeing all of it in the table form, now you see in the summary. See, it had so many rows, the 27,000 something. Now it has 8 rows just to show the summary statistics. So I'm just going to take one quick pause at this point to ask if anybody has any problems up to this point. And all we have done so far is to look at the summary of the data. Okay, so moving on. And I know we have about 10 minutes. Today's session is a 90-minute session, but we can stay back a little bit after for those of you who need, so that's fine. Okay, thank you, Luana. I successfully uploaded the, not sure it's where to. No problem at all. Don't worry, we'll come back and show you, right? So just to give the rest of you just an umbrella of the rest of what we're going to do, we're going to look at the different types. Now, remember, I told you all, one central thing is the data has different data types, the way the data looks. So you have nominal data, nominal data is categories. So I keep using the word categories, but you could put categories into different, I want to say subcategories, but you could have nominal data where it has no specific ranking, like for instance, gender, or you can have ordinal data where we have to put things in a rank, like say education levels, etc., low, medium, high, as I mentioned before. Sometimes it's nice to actually to put the data into that format instead for certain purposes. So let's see how we could run this one in terms of the categorical features now. We looked at numerical before, and the categories you could see in terms of words, the worded version. So the payer type, the patient race, and all these different things. The type of breast cancer diagnosis, etc., the codes. Now, as I said, we're just looking at what the data set had. For instance, you'll see this word mark NaN, where it has no values there. So it will show up like that when it has no value in that specific space in the data. Remember, we're dealing with rows and columns, and these supposed to show where the data was lodged. So this is just a quick look. Now, I don't know about you, but for me, it's getting tedious to keep watching the data because at some point, we're going to have to think about, well, how do I look at this in a nicer way, right? So let's scroll down and see if when we go through the overview of the data set, so we could go past the overview of the data set now, because we kind of have an idea. And we just want to stop before we do that. Just think about very quickly now. I'm just going to mention this very quickly about missing values. There are a number of ways to deal with missing values. So we'll give you all a few ways, but as I said, there are different ways. So it's not a one science. It just really depends on what the variable is and how it looks. So you could read through and see what we mentioned about looking for missing values. So when we spoke of missing values here now, we were seeing, like, for instance, when we looked at the data set, patient race and these things had different missing values. So if we want to check, we could actually run the code to check for missing values within our specific data set. And here you see we could print the missing values. So we had put in some extra to print missing values greater than 0. You could see now, look how many missing values of patient race and payer type. And that could influence your so depending on the number of data points in your data set, it could have an influence. Now we have a very large data set, so we're very lucky, right? And as we go past that, display the variable name, so we can do other things. So we added in a lot for not only beginners, for others who are more intermediate. We could actually display the column names and tell us what. So in a sentence form now, it's actually telling us patient race has how many missing values, etc. So this is a little more intermediate, right? So as I said, for all of you who are looking at it, it's just to give you a feel for the language. Missing values tests, there's other ways of doing this as well. So we could test to see, right? And as we go along, so we could scroll down. So as I said, you could go on and run these, but what we really want to do is, yeah, so we could just go on and just keep running the rest of them. What I want you all to think about now is, I'm doing all of this, but how do I know what it's telling me? Especially like here, where we want to look at the different visualizations. So for instance, right, patient race, for instance, we have these numbers, whites, blacks, Hispanics, and you see the numbers there. So you see the, I don't want to call it disparity, but you actually see how some may be larger than some. Asian is the least in the study. So you may think that there may be biases. Maybe some people, it's either there are biases in terms of some people may be more prone, or they did not record. Maybe certain people, certain races we didn't have recorded. It just said it could be anything, right? But these are the questions you have to ask ourselves. So let's kind of visualize it now. So in our exploratory analysis, we want to kind of visualize, because I like to see diagrams and graphs so I can actually have an idea of how does this really look in real life. So it's crucial to understand, because as I said, if you look at it in numbers form, you may want to see it together to make a better discernment of how the spread of the data looks. So we run this code on the visualize columns. And in this specific case, we chose it looks like a histogram. It's like a bar chart without spaces. And I want to impress upon you again, one of the key takeaways you'll always remember, the specific type of variable goes with a specific type of graph. So specific, like numerical variables, you could use histograms, etc. Categorical variables, ones with categories, you would want to probably use pie charts, bar charts, that sort of thing. You might have line graphs and those things from numerical. So there are different types of graphs, right? So this one is showing, so you can actually see the treatment period and the frequencies, and you could see how it's very high here initially. And as the days increase, or the treatment period days increase, you could see how it goes down, and it goes almost to the axis there, and the frequency goes down sharply. Right? So it's kind of skewed or biased more to the left in terms of the initial period of treatment. You have a lot of people in there. So for that numerical variable, that works. And as I said, if anybody has any questions, you could let us know in terms of any of the content, right? What about race distribution? We may want to see how that looks in terms of how we spoke about it before. So in this sense, we have now some key ideas or concepts about the proportions, because you could look at it in terms of percentages. Sometimes the percentage actually is easier to think about than just the actual count of the different persons or in the study. So you could read through this on the advantages of using a pie chart, and we will do a data visualization session in the third workshop to go through each of these in more detail. So just run this code here so you can have an idea. And this is how it looks. And I'm sure you think, wow, look, it brings it to life, right? So you could see now everything in terms of the percentages, and you could see which specific race in this particular data set is more dominant. And this is the distribution as we see, right? So we could consider pie charts as we mentioned, and you all could always go through the different spaces. So let's just continue running the code because we just want to get to a point, and you could also do it for the different regions where the patients came from, etc. So it's a similar task, right? Now we'll just quickly talk about the pre-processing and the cleaning. So we're going to just run, so I'll just invite you to just run the code as I speak about it as we go along, where we would think about now the data that we have. More of them had half the missing values. So we removed some of those columns just for this particular demo. We removed those specific columns, and these are the columns we're working with right now without columns without half missing values, because we felt that would bias what we are doing in terms of prediction. So it tells us the columns that we removed, right? So we're just cleaning up the data a bit. And as we go on, we can identify columns with more than half missing values for the test data set. So we could do it for the 2 data sets because it's important to do the same tasks for both. Remember, they have the same specific data, just one has the target variable. Because remember, we want to, in the end, do a prediction. So we could go along again, just cleaning up the data. So you could run these codes, and then you could print these specific columns now. So you could see which columns we actually extracted there doing that processing, right? In both of them, the training and the test sets. And this is a key step in terms of creating a copy of the data sets. Because what happens is sometimes you want to actually not work on the specific and make too many changes to the original one. So you want to create a copy so you can continue doing what we call feature engineering, where you want to create different features. So we would encourage you to create, and this is a more intermediate step. So beginners, don't worry, right? This is a more intermediate step, but this is what we encourage. So you could run this code, and you could see it's just the same copy of the same data that we did before. And we could actually have the pair type now. So we copied that data. So we just showing you how to copy a specific column if you wanted to copy that column. And then there are other steps. So as I mentioned, we showed you a myriad of different ways we could do these things, imputing columns with numerical values, and then modes for categorical values. Now there's a way to impute. And as I said, in our follow-up workshop in terms of data visualizations, we will talk more about some of these methods. But this is where we could see you could actually use this for columns that need put in data where there was no data. If you have a lot of missing data, you could actually put in the mean value, right? And you could run this code. Anybody has any questions? I'm seeing Anthony's asking, generally, would it be preferred to remove features or replace missing values with mean, median, etc.? Well, Anthony, it really depends. I'll give you my answer, and I think Nicholas will also give you his answer too. Just off the top of my head, I'll tell you that a lot of the times it depends on the specific features, and it really depends too sometimes on how the data looks, if it has a lot of outliers, etc., if a lot of data is missing. If it's just mean and median, usually they will say the mean, but as to put it in a more technical sense, you have to look at the distribution of the data, and sometimes if the mean is better than the median for that purpose, depending on how the data is looking less symmetric. If it's very biased, you might want to probably use the median, but it's really dependent on the way the data is distributed, as a short answer. Nicholas, you want to add anything to that?
What was the question again? Sorry.
He said, in terms of removing features or replacing missing values or with mean or median, and you can remove, a lot of the times you could remove features, but I don't want you all to remove features blindly. So Nicholas, you could talk about that too. It really depends on how important it is to the study as well, because remember, you might think it doesn't look important, and then for the specific study, it's important. So Nicholas, you could probably also respond on that too if you want.
Yeah, as Dr. Addison said, it really does depend. And I know as we're going through this, it's like a sequential step where we analyze the data, you do EDA first, then impute and pre-process the data, and then create a model. But this, you don't really have to follow the strict sequential step. You could always go back and do EDA. You can always go back and drop or add back the columns or drop more columns. And if you want to find out what columns to keep or drop, You can also use a model to tell you which features are important, or use a correlation matrix to understand which features you will want to drop or keep.
Exactly. And that's really important because in terms of correlations now, that's where you'll see some of the relationships. And we could go on to show you that after. So as I said, we have a lot of intermediate steps that you all could run as you go along, but let's just kind of show you a quick, yes, thanks. No problem, Anthony. And we are happy for the questions. And feel free, if you all run it on your own time, feel free to reach out to us again on it. We're happy to take the questions about it, right? So we're just going to keep running these codes. And I know we are close to, well, we are at the end of the session here. The last couple things we want to show you, because we will actually do it in a larger way in our other workshops, is that eventually when we do all of this analysis, we create all of these graphs, as you could see here, as we mentioned before. We look at the correlations and we look at box plots. We look at a lot of exploratory things. Then we could be in a position, as Anthony had mentioned now, we will see which features we could keep, which we can't, and then we will decide to go on and build a model from there. So we will actually do processes like, for instance, encoding the categorical columns. As I said, all of these are processing the data in some way. And Videsh also mentioned if the data set is small, it could impact. Yes, so it really depends on the size of the data as well. So that's a good point as well, right? So correlations, we did a version for you all to see how the correlations, relationships would look. So you could continue to run through these, and we will use that to actually say if there were relationships there that were meaningful. In terms of this one, we could see breast cancer diagnosis, yeah, it had a negative correlation in terms of the treatment variable, etc. So the correlations of these variables are small. Most of them are small positive correlations, except for that one. There's another one further down, yes, the treatment PD. So it has like an inverse relationship. As one increases, the other decreases. And as I said, we'll talk more about these metrics when we build any model. But it's really to give you all a feel for what it looks like. And then we would have to train the model. So in workshop 3 or 4, we will actually go more into training the model. So we have everything in here for you all to see and for you to run through. And in terms of linear regression, we could run this code, the same metrics I mentioned that we need for the Kaggle to upload there. We would have them actually the actual metric of the mean square error and the model.predict function. So when you run this code, you would see at the end, we get the mean square error. We also get others called the root mean square error. It have a lot of different metrics you could generate. You could also generate what we call an ROC curve too if you wanted, which is based on the accuracy of the model as well. But these are the metrics you need for uploading. And then once you do that, you could plot. And as I said, we just for purposes of your understanding, we did different plots so you could see how the data looks. But the model evaluation is based on these specific metrics. You could read through what they mean mathematically speaking, but this will tell you how well the model is performing and if you want to improve. So for instance, if you see that your model has like 0.76 in terms of the value, you could always say, you know what, I need to do some more feature engineering. So as Anthony might say, you know what, maybe I need to do some more on this model to actually improve the way it performs, right? So that's the model performance. So there are different metrics. And as you go down at the end now, you would notice after training. So remember what we would do, we would train in and then we need to validate, because what do we need to do? We need to make sure that these predictions actually fit for the actual data that we had and they are accurate. So we go now and we run test predictions. So we use the same model predict, we use it on the test data, right? Because we need to look back at the test data now to see if it's given us good predictions for the unseen data, run that. And then at this point in time, when you run this, you want to create a submission. So this is the step that a lot of you who want to be more intermediate. As I said, remember, for beginners, we will go through all these steps every week. So we'll get to the submission point. For people who are more advanced, this is where you would want to get your submission step after you do all these other steps. The submission CSV file. So we create the file called submission and change it into a CSV. It will save it to a CSV file. And do you notice what happens? It actually creates it here. So when you run this code, it creates the submission file that you need to upload on Kaggle. So if you watch the video that I had earlier, it's on our WiDS YouTube website. Maybe we could put that in the link for them, and we could actually tell them you could go on the WiDS YouTube website for us, and you could see that video again. So you could see there and download it. So now you download your submission file, Could we download it and show them, have a look and see how it looks? So once you go through these steps, it creates that submission file for you. And then this is what you will be submitted. So Anthony, if you're in the competition and you go through it, you could create a submission file. But if you find the RMSE score is not where you want it to be, you could go back and you could do some more feature engineering. And I think there was a question in the chat. I know we are a little over time for those of you who wanted to do the 90 minutes. As I said, we're here until 3 for this session. All the other sessions are 2 hours long. This was just an introductory one. But Priya is asking, what does a feature age under 10 and similar features like age under 30 mean for a particular patient? I think those features, so they had specific percentages. What happened in this data set? They also had percentages based on, for instance, the representation of the data in those states, in those particular areas. So you would find like you're feeling like there are duplicates of certain variables in a way. So just so what Priya was asking, we'll just show what she meant. When you see all of these, sure, we'll send you all the recording, right? So yes, so you see the percentage of residents, it's based on the percentage in that specific, in the states, in the specific states. But then they also recorded the actual ages of the patients, but they also have this representative data. Maybe it's from survey data or census data that they have those percentages, even for the races as well. So they have quite a lot of data, probably so that we could also ensure that when we look at the races that we have here in our data, that it is representative of what's in terms of the actual different states that are involved in terms of the study. Because remember, you could actually have a completely biased thing where there's only one specific race within the study, and it would be representative of the population of the United States, right? So that's a good question. So we will stop at this point and ask for any questions. Remember, as I said, it was a very loaded notebook because we have a lot more in terms of other analyses. We did a classification as well. We did for more advanced people, XGBoost, which is another kind of regression model. The classification section, for those of you who are interested, you can go through this one because in fact, this particular datathon is actually based on classification. So we showed you regression because that's the simplest way to look at predictions. Classification is based on a yes and no type, like a binary type of score. Like you're actually saying, well, is it that it's a yes or a no in terms of the target variable. So I know some of you had some challenges with the file, so I can stop here and just open up the floor to ask you any questions, and we'll just do the second poll before you all leave and just ask you, what do you think at this point, having gone through this particular session, how do you feel about the data science? Is it easy? One being difficult and 5 being easy. I see some people, 3. Wow, interesting. 75% of y'all are in neutral. Are y'all seeing the results by chance? So 66, so I've given you all some data science stats. 66% of y'all have 73% participated now. And yeah, so we're seeing about 64% of you. Some people saying it's hard. If you feel it's hard, that's okay. Remember, this is if it's the first time you're doing this, remember we're showing you at a high level. So for those of you who want to continue joining us on these Saturdays, you'll get step by step. And of course, we will also go into R as well. Yes, the application of software takes time. I agree, Anthony. Anybody else? Everybody seeing the poll results by chance? I'm not sure if you're seeing it on your end, but I'm just reading it off from what I'm seeing, right? So I'm going to end the poll now, but thank you. Oh, you all can't see the results. I thought you could see the results. Okay. Well, in fact, from my end, can't see it. I'm so sorry. I'm seeing it on my end, but I'm not too sure why it's not showing up on yours. But it either way, it's are y'all seeing it now by chance? No? Well, if that's okay, that's okay. I'm not too sure why I couldn't get it to share. I was sharing it earlier, but I'm just going to end it now. So, oh, now we could share. Right, seeing it now, right? So that's what it looks like for now. And that's good. 67% of y'all are in between. So what I would say is, when you get chance, go through. For those of you who had problems, feel free to let us know now. We can always stop the recording. But before we stop the recording, I would just like to thank you all for joining the session. It's been very meaningful to have you all here. We have a workshop feedback form in the chat. Are there any final questions from anyone? For those of you who want to stay back and just ask us about the running of the notebook, feel free to do so. Okay, so I'm going to stop recording the session now. Thank you everyone for joining us. Let me just remind you that we have some more sessions next week. So before we sign off, I will just show you, this is what we have coming up for you in the next session, which is basically overview now. So you can go on our website and you could see, right? So this is what we will be doing next day. So that will be next Saturday, looking at the data science tools. So we're also going to talk about R, MATLAB, and for persons in social sciences and other areas, even things like Google Sheets, some of them may not have the capabilities as say Python and R and these open source tools, but we'll give everyone an idea of other tools that you can use just for other types of insights. So that's next Saturday at the same time. And remember, it's that will be a 120-minute session. So we go for the full 2 hours. So you have enough time to sit down, and we will send you the resources before once you sign up. And then you could see the rest of the sessions you want to go jump into for the next weeks, right? So thank you very much, everyone, for joining. I will post the slides for you as well in the folder. And of course, the recording will be sent out to you. And if you want to connect with us on LinkedIn, our YouTube channel, and our website, feel free to do so. So until next time, take care.